two samples are being combined. Sample 1 has n equals to 5 scores, and it has a mean of 10. And sample number 2 has n equals to 10 scores, and it has a mean of 5. What is the mean for the newly combined set of scores? Okay, so what we're looking at in this case is what's called a weighted mean. We are going to be looking at we're looking at the average of two groups being combined, or the average of their averages. Now, taking the average of their two averages is not going to give us the right answer just as simply as that. So, for example, my first average is 10, my second average is 5. If I add up the two of those, I'll get 15. Take 15 and divide by the total number of averages. 15 divided by 2 is 7.5. This is not going to be the right answer. Just taking the simple average of these two averages, it's not even an option in here. So why is this wrong? Well, consider that there are 5 people in the first group and there are twice as many people in the second group. So the second group is giving more weight to the overall answer. If that's confusing, just think about it this way. Let's say we have somebody who's 10 years old and somebody who's 20 years old. What is the average age of these two people? Well, you could work it out mathematically. You could say 10 plus 20, that gives me my total, divided by two people, gives me 30 over 2 is 15. The average is 15. You could also consider that 15 is right in the middle, which makes sense. If you have two people with these two ages, their average age is going to be in the middle of their two scores. But what if you have more than one 20-year-old? What if you have two 20-year-olds? Certainly that's going to bring the average age of the whole group up because you have more older people now. Obviously that would work out if you do the math again. If I did 10 plus 20 now plus 20 again and divided this by 3, I'm going to end up with 50 divided by 3, and what is that? 50 divided by 3 gives me roughly 16 point, well, I'll go to 4 decimal places. It's higher than 15. The average has now increased because we have an extra older person. So because there is a larger amount on this side, the average gets pulled towards that group. The same thing is going to happen here. Look at group number 2. Group number 2 has twice as many scores in it. Sample number 2 is twice as large, and so we should expect an average that is closer to 5 than it is to 10. But how do we work this out exactly? Well, there are a couple of ways presented by your textbook. And the first one, let me just make a little bit of space here. The first one is a formula that looks like this. My mean is equals to the sum of x for the first group plus the sum of x for the second group over the first group size plus the second group size. Now we don't have the sum of x for each group, which is kind of annoying because we're going to have to do some math to get each of those. Your formula for the mean is the sum of x over n. If I want to get the sum of x by itself, I need to get that divided by n out of there. So I'm going to multiply both sides by n. These ones will cancel, and this leaves me with the sum of x equals n times m. The sum of x equals to n times m. So n, 5 times m, 10, 5 times 10 gives me 50. And over here, in sample number 2, n is 10 times 5, and that gives me 10 times 5. Coincidentally, ends up also being 50. So I can now work out that 50 plus 50 over my first sample size is 5, plus my second sample size is what, 10. This is going to give me 100 over 15, which if you work it out is 6.6667. So 6.6667. That is my new mean. That's one way of doing it with this formula. But there is another method. They spell it out in the textbook, or they give an example of it, but they don't actually show the formula. Now, the formula would look like this. It's your first sample size over n1 plus n2, the total sample size. This is multiplied by my first mean. Then I've got my second sample size over, again, the total size of both samples taken together times m2. So this one ends up being what? 5 over 5 plus, what is this? 5 plus 10, 5 over 15. And my first mean is 10. Add this to the second sample size, which is 10. Total sample size is 15. And then this is multiplied by the average of 5. This might seem a little bit more confusing at first until you think about it this way. 5 out of the 15 people have an average of 10. 10 out of the 15 people, once we've combined our set of scores into a single set, 10 out of the 15 people have an average of 5. So it might look like a big ugly formula, but it's actually a little bit easier to keep track of what you're supposed to do, and it doesn't involve rearranging any formulas like we did here, and because we didn't have what we needed for the formula that was spelled out in the textbook. So this one, where you just figure out what proportion of people have the first average, multiply that out, and then add it to the proportion of people that have the second average. So 5 out of 15, that ends up being 0.3333, times that by 10, plus 10 out of 15 is 0.6667 times 5. And you'll find that when you work this out, you end up getting 3.3333 plus 3.3333, or actually 4, I think, and you get the same answer as we did before, 6.6667. So no matter how we do it, we end up getting that it's a total score of 100 divided by a total sample size of 15. This gives us 6.6667.